Hi, this is Lingyao. I'm going to give a short introduction on our work, Map Adaptive Goal-Based Trajectory Prediction. To ensure the safety of self-driving, it is critical to predict the long-term behavior of the vehicles in a traffic scene. However, there's a lot more uncertainty when it comes to the longer horizon of the actor's behavior. In this work, we take advantage of the observation that human drivers usually follow the road network very well. In our approach, there are three core modules. The first module, Goal Proposal, where we propose a set of goal paths for each actor based on the local map geometry. In the second encoder module, we use an RNN encoder and a 2D convolution encoder to encode the actor state and the scene context respectively. One thing to note is that the scene context is represented in the frame defined by the path. In other words, each path has its own view of the world. In the last graph network module, we use it to make predictions based on the encoded features. The final output of our method is a set of goal-based trajectory relative to the goal path, and goal-free trajectory that are fully based on the actor's current motion state. We did experiments on both the internal and external nuScenes datasets. You can see that our method outperformed the previous state-of-the-art on almost all the trajectory metrics. We also show that our method has a much compact output representation, in a sense that we have a very small set of output modes. One thing to note is that there's also variance in the number of output modes in our method. That suggests that our method can adapt to different local map geometry because we generate a path based on the local map. We also did a generalization experiment where we train all the models on dataset from one city, but we evaluate them on a dataset from another city. You can see that our method has the least regression. Lastly, there are some qualitative examples. In the first unusual five-way intersection example, you can see the trajectory output from our method is much more spatially diverse than the previous state-of-the-art like MTP and multipath. In the second curved road example, you can see the trajectory prediction of our method follows the lane very well, while MTP and multipath seems to extrapolate the actor's current motion state. In the last off-map driving example, even though we do not generate a path that could capture the ground truth behavior of the actor, our method can still roll back to the goal-free trajectory prediction to recover the ground truth behavior. Thanks for your attention.